Good morning, students. Today we are discussing catalytic hydrogenation, Clemmenson reduction, or Krishna reduction, Mervyn point of parallel reduction with LAH, NaPH4. So, first one catalytic hydrogenation. Okay, what is catalytic hydrogenation and how to use it? So, first one catalytic when carbonyl compounds are reduced by molecular hydrogen using catalysts such as PT, PDR, and nickel, it results in the formation of alcohols. Okay, what happens when carbonyl compounds are reduced by molecular hydrogen? Molecular hydrogen means that related using alcohols or H2 or H4, some others. So in that hydrogens are reduced. Okay, hydrogens reduced. So the formation of product is called catalytic hydrogenation. Catalytic hydrogen means about reduction of hydrogen from molecules is called catalytic hydrogenation. Okay, catalytic hydrogenation. Okay, is hydrogen of aldehydes, acids, and acid chlorides yield primary alcohols, while ketones yield secondary alcohols. Okay, hydrogenation of aldehydes. Okay, aldehydes, you know that aldehydes, acids, and acid chlorides yield primary alcohols. Okay, what's the aldehydes? Aldehydes, we know that RCH4. Okay, next one acids, OH, COOH. So next one acid chlorides, COCl. So this is acid chlorides. Primary, this all belongs to what CH4 group, COOH group, COCl group. This all belongs to primary alcohols. Okay, primary alcohols. Next one ketones. We know that ketones RC111. So also only secondary alcohols. Okay, secondary alcohols. This is primary alcohol, this is secondary alcohol. Okay, in that you know that RC double bond H plus H2. Okay, in terms of H2 platinum. So what happens? RC HOH. Okay, this is the primary alcohol. Okay, for example, RCH double one plus H2 in terms of H2PT. So what happens? RCH HOH. So in the two, what happens? This OH is present in the only one alkyl group is present. So this is a primary alcohol. Okay, next one RC double bond O R dash. What is this? RC double bond O R dash means ketones. Okay, this is ketone. Why? Because this ketone function group is RC double bond O R dash. So this is RC double bond O R dash. So in terms of H2, what happens? In terms of H2PT platinum, what happens? RC R dash H OH. This is two alkyl groups present. So this is a secondary alcohol. Okay, this is secondary alcohol, that is primary alcohol. Okay, this is primary alcohol, this is secondary alcohol. In the term, we take examples CH3 CH4 plus H2. Okay, that's a platinum. What happens? CH3 CH2 OH. So this is the ethyl alcohol or primary alcohols. Okay, next one we can take CH3 CO CH3 plus H2. Benzene of platinum, benzene of He2. What happens? CH3 CHOH CH3. So it's the isopropyl alcohol. So what should we take this? Second alcohol. Why? Because this is aldehyde group, this is a ketone group. We are discussing in definition also what we are discussing. Hydrogen of aldehydes, acids, and acid chlorides yield primary alcohols. Okay, and ketones yield secondary alcohols. So this is the aldehyde. So that is primary alcohol. This is ketones. This is called secondary alcohol. Okay, students. So next one, this is the catalyst hydrogenation. Next one, Clemmensen reduction. Okay, Clemmensen reduction means chemical reaction that describes the reduction of carbonic compounds to alkanes. Okay, what is the reduction of carbonic compounds? So carbonic compounds means we know that C double bond O or COOH or CHO. This is all carbonic compounds. This is converted into CH3, C2H5 or C3H7. This is alkanes. Okay, the carbonic compounds directly converted into alkanes. That is called Clemmensen reduction. Okay, in other words, elements. Clemmensen reduction is a method used for converting C double bond group to CH2 group. Okay, we have discussed. Okay, aldehydes and ketones when treated with amalgamated zinc and concentrated hydrochloric acid under reduction to give alkanes. Okay, students, this is aldehydes and ketones. This process of reduction of carbonic compounds known as Clemmensen reduction. Okay, C double bond. Okay, this influence of Z and Hg. So concentrated HCl carbonyl compound. So in that alkane parent. For example, we can take what we should take CH3, CH2 thrice CHO plus 4H. What happens? So in the sum 1, 4, 5, total in 5. So pentanol. All comes from CHO. CHO means aldehyde group. So this is from all. So pentanol. So in presence of 4HO, zinc amalgam, what happens? CH3, CH2 thrice CH3. So what happens in this O molecule is combines with HO. So 2H2O. So in this 2H molecules combines with O goes to H2. Water molecules are outside. So what happens? So CH3, CH2 in this 2H this combination is thrice CH3. So this is called how many carbons? 1, 2, 3, 4, 5. So N pentane. So what is the definition? Carbonic compounds converted into alkane groups. That is called Clemmensen reduction. What happens in this? We can take CH3, CH2 twice CH4 plus 4H. Okay. In this, what happens in this 2H atoms combines with O to form in presence of Z and Hg. So what happens? H2 is formed. Okay. In this H2O, where we do. So next one is CH3, CH2 thrice CH3. So what is this? N-pentane. Okay, this is N-pentane, and that is N-pentane. And next, what should we take? So in this mechanism also mechanism, what should be the mechanism between the formation of the Clemmensen reaction shown in figure. So RC double bond for R. So this is the keto group. Okay, this is keto group. In this double bond will convert into single bond. What happens? Zn Cl minus. What happens? RCO minus Zn Cl. Okay, this is next in presence of H plus. What happens? OH Zn Cl R. Okay, in this what happens in place of H plus H2O. Okay, in this H plus combination with OH minus, what happens? H2 is outside. So RC positive carbocation form Zn Cl. Okay, in this Zn removed, only Zn you can take. So what happens? Zn Cl is outside. So RC Zn minus plus R. So what happens in this next Cl, we can take Cl. So what happens? R, C, Z and Cl are double bond. Okay, this is lone pair negative charge. So what happens in presence of H plus? What happens? R, C, H, Z and Cl R. Okay, in this is H plus we can take. So R, C, H, 2 R. So Z and Cl is outside. What we should take? First we can take a keto group. Okay, in this keto group, in presence of Z and Cl, what happens? R, C, double bond breaks. After that, what happens? O negative charge. So O negative charge R. Okay, in this Z and Cl comes to carbon atoms. So in presence of H plus, what happens? RCOH. This H is converted into O minus. So what happens? RCOH are Z and Cl. In presence of H plus, what happens? H plus and OH minus combines to form H2O. So in that OH is gone. So that's why in this only positive charge is Rc plus Z and Cl R. Okay. In this Zn we can take. Same atoms are not like does not match in same word. So Z and Cl is outside. So we can take Z and Cl outside. So what happens? This Zn is go to this side. Okay, Zn plus negative charge. Zn minus go to positive charge. So what happens? Rc Zn Cl R. This is lone pairs and negative charge is said. So in this negative charge we can fill that H plus. So what happens? R, C, H, Z and Cl R. So in this H plus another H plus we can take. So what happens? R, C, H, 2 R. This Z and Cl to go to outside. This is the formation R, C, H, 2 R. This is the mechanism of Clemmensen reduction. This is the formation of alkane. Okay, this is the formation of alkane. This is the Clemmensen reduction. What we should take? First one, Clemmensen. Clemmensen reduction is a chemical reaction that describes the reduction of carbonyl compounds to alkanes. Okay, carbonyl compounds to alkanes. In other words, Clemmensen reduction is a method used for converting C double bond group to CH group. Okay, this carbonyl group to this alkane group. Aldehydes and ketones when treated with amalgamated zinc and concentrated hydrochloric acid undergo reduction to give alkanes. Okay, this is alkane. This process of reduction of carbonyl compound is known as Clemmensen reduction. Okay, C double bond carbon compound Z amalgam concentration. What happens? Alkanes is formed. So in this we can take example. For example, CH3 CH2 thrice CH4 plus 4N. This is pentanol. Okay, this is pentanol. Pentanol means where in CH4 means aldehyde group. So this is pentane. Why? Because pentane 5 carbon atoms are present. So this is pentanol. So in presence of zinc amalgam and HCl, what happens? N-pentane is formed. In this OH, this H, so 2H plus O, 2H H2O. So this H2O is outside water molecule. Next is aldehyde, propion, phenol also same like this. Okay. In this mechanism, the mechanism with the formation of Clemmensen reaction below. So RC development in presence of Z and Cl. RCO minus Z and Cl R. Okay, in presence of H plus, what happens in this RCOH Z and Cl R. Okay, this is carbon compound. H plus, what happens? H2 is outside. So RCr Z and Cl. Okay, students, this one. So in this Zn we can take Zn minus. So what happens? This Zn minus go to this side. So this Zn Cl is converted to outside. So Rc plus Zn minus plus R plus Zn Cl. Okay, in this RCr Zn Cl lone pairs and negative charge. What happens? H plus RCH Zn Cl R. So in this presence of H plus, what is RCH to R alkane? This alkane is formed in this method. Okay, this is a Clemmensen reduction. This is also very important for examination. Next, Wolff-Kishner reduction. Okay, Wolff-Kishner reduction. What is the Wolff-Kishner reduction? Wolff-Kishner reduction is an alternative product procedure conventional reduction. This reduction method is the treatment of hydrogens, semicarbonates of ketones and aldehydes with alkyls such as C2H5 in the presence of ethylene glycol temperature. This results in the combination of composition of hydrogen to yield a hydrocarbon or alkynes. Okay, This is the method to use the hydrocarbons. Okay, in this we can take C double bond O, presence of NH2 NH2 alkane. What happens? Alkane is formed. This is also same. What happens? C double bond O, carbonyl group taken. So in presence of O, NH2 NH2 carbon group. So in this alkane group is present. So this is carbonyl compound. This is alkane. Okay, these two are combined. So so in this it is also same to Clemmensen reduction. Okay, C double bond. Okay, NH2 NH2. So alkali. So CH2 alkane is present. Okay, in this we have to take in order to reduce the semicarbazone and azanes, this have to be converted into hydrogen first. Okay, this have to be converted into hydrogen first. Okay, this we have to take a semicarbazone. Okay, this is called semicarbazone. So in terms of water molecule, what happens? So RCR, so double one NH2. So this combines with this total carbon. So next one we have to take RCR dash double one N double one C R dash NH2 NH. 2 moles of CR dash double one NH2 plus N2. So what happens? This azane, this is a azane. Okay, this azane converted into NH2 NH2. What happens? This total forms. Okay, in terms of examples, what examples we should take? C6H5 C double bond to C2H5. This is a propiophenol. Okay, what is a propiophenol? So in presence of NH2 NH2 hydrogen, what happens? C6H5 C double bond in presence of one H2 molecule is combines with O. This H2O. So H2O is outside. So what happens? C double bond and H2. So in the KOH glycol is point to C6H5 CH2 C2H5. What happens in this N2 molecule is outside. Why? Because this carbonyl compounds is converted into only alkanes, not hydrogens and some other examples. So that's why we can take C6H5 CH2 C2H5. This is in presence of N2. So this is what is this? Propiophenol, phenyl propione. Okay, phenyl propane. So in that cyclohexanone we can take. So in this in presence of hydrogen, what happens? This glycol is present. In presence of glycol, what happens? This NH2 is outside. So cyclohexanone is formed. Okay, this is a KOH solution. Why? Because we can take this is the double formula cyclohexanol in presence of NH2 NH2. What happens? So NH2. So in that in presence of glycol, what happens? Cyclohexane is formed and N2 molecule is outside. So this is some examples. Mechanism. What should we show? Mechanism of This mechanism, you can take the mechanism indicating the formation of alkene using Wolff-Kishner reduction is known as below. So what happens in this mechanism? RC dash double bond N H. So in this H can OH2. So RCR dash and double bond N double bond H. Okay, this is H with pressure of OH H2 is formed. So CR dash double bond N and H2. Okay, this is formed. So in presence of H2, what happens? RCH R dash N double bond N H plus OH. So in presence of OH H2 were formed. So RCH R dash N double bond N. So N2 is molecule formed. So RCH R dash H2 OH H R dash H. This is the mechanism. The Wolff-Kishner reduction is mostly commonly used in the formation of synthesis of synthesis. So this is RC H R dash. Okay, this is in H2O. H. Okay, this is mechanism of the Wolff-Kishner. Good morning, students. Today we are discussing about the preparation of aromatic aldehydes and ketones from oxidation of arenes, hydrolysis of benzyl halides. Okay, arenes means we know that we discussed in previous class also. Arenes means specific structure which containing functional groups in ring formation, that is called arenes. Hydrolysis of benzyl halides means benzyl means benzene structure. Okay, you know that benzene structure, okay, with containing halide groups. Okay, this is halide group, that is called benzyl halides. Okay, students, so we are discussing about preparation of aromatic aldehydes and ketones from oxidation of arenes and hydrolysis of benzyl halides. So first one, oxidation of arenes. Okay, first we are discussing about oxidation of arenes. Thus major methods applicable for the preparation of aldehydes and ketones are oxidation of aromatic hydrocarbons. First one, in the first one, oxidation of arenes, oxidation of aromatic hydrocarbons. The oxidation of aromatic hydrocarbons such as toluene. Okay, this is the toluene. The benzene ring which containing methyl group is called toluene. With manganese dioxide. Manganese dioxide means MnO2. And sulfuric acid, benzaldehyde. Sulfuric benzaldehyde means we know that sulfuric acid. You know that sulfuric acid means H2SO4. Okay, H2SO4. So to form benzaldehyde and aromatic aldehyde. Okay, benzaldehyde and aromatic aldehyde. First one we can take toluene. So toluene in presence of manganese dioxide and sulfuric acid to form that is, so CH3, where CH3, this is CH3. CH3 in CH3, manganese dioxide and H2SO4. H2SO4 means sulfuric acid. These two are combined. So these two are combined to form this CH3 convert to C double bond OH. That is called benzaldehyde. Okay, this is called benzaldehyde. Next one, third reaction. In this reaction, toluene is oxidized. Okay, this is also toluene. We can take toluene. So toluene is oxidized to aromatic aldehyde. Okay, aromatic aldehyde. Benzaldehyde in the presence of an oxidizing chromyl chloride. Okay, benzaldehyde in presence of oxidizing chromyl chloride. The chromyl fluoride oxidized to methyl group. Okay, chromyl chloride is converted into methyl group to chromium complex, which on hydrolysis gives a product. Okay, first we can take toluene. So in the toluene, the presence of chromium chloride, chromium dioxychloride, and cesium. Okay, cesium in the presence of chromium dioxide to form chromium complex. This is the chromium complex. We know that complex. What is complex? This is the center atom which containing 4 or 6 octahedral or tetrahedral complexes. This is the complex. What is complex? We can take an example Fe. So this is the complex, or Fe. This is the complex. Okay, these total two are complexes. So in that this reaction toluene is oxidized to aromatic aldehyde, benzaldehyde in the presence of an oxidizing agent, chromyl fluoride. Okay, this is the chromyl fluoride. The chromyl chloride oxidized methyl group to chromium complex, methyl group to chromium complex, which on hydrolysis gives the product. So to form chromium complex, in presence of hydrolysis to form benzaldehyde. What is benzaldehyde? The CH2 group or C double bond OH group which is containing benzene ring. It is called benzaldehyde. Okay. Next, Gattermann-Koch reaction. Gattermann-Koch reaction. In that Gattermann-Koch reaction, this is the most important question. Aromatic aldehydes can be prepared when arenes are treated with a mixture of carbon monoxide and hydrogen in the presence of anhydrous AlCl3 and a trace of cuprous chloride CuCl. Okay, this is the arene carbons or benzene in presence of carbon monoxide, in presence of hydrogen chloride. So in presence of AlCl3 and AuCl3 to form benzaldehyde and HCl. Okay, students, aromatic aldehydes can be prepared when arenes are treated with a mixture of carbon monoxide and the trace of anhydrous AlCl3. So the trace of cuprous chloride. Okay, cuprous chloride in presence of benzene, carbon monoxide and HCl, hydrogen chloride. To form the students, we can take this is the benzene and the carbon monoxide and the HCl. Okay, in presence of AlCl3. AlCl3 means aluminum trichloride or aluminum chloride, and that is some AlCl3 and Rm, mercury chloride. Okay, to form CH4 plus HCl. Okay, this is the structure. So first one we can take benzene in presence of carbon monoxide, in presence of hydrogen chloride, in presence of AlCl3 and mercury chloride. So to form benzaldehyde and HCl. Okay, this is the formation of Gattermann-Koch reaction. What is that? Aromatic aldehydes can be prepared when arenes are, this is the arene. Okay, arene or benzene. Okay, students, arenes are treated with mixture of carbon monoxide and hydrogen chloride in presence of aluminum, anhydrous aluminum chloride and a trace of cuprous chloride. This is cuprous chloride. Okay, CuCl. Okay, cuprous chloride to form benzaldehyde and hydrogen chloride. Okay, student, this is the Gattermann-Koch reaction. Next one, by side chain chlorination of toluene. Okay, that by side chain chlorination of methyl benzene forms benzyl chloride, which on hydrolysis gives aromatic aldehyde. Okay, students, in that first one we can take toluene. This is the toluene. Okay, the CH group which is attached with the benzene ring to form toluene. So in the presence of toluene, Cl2H2 to form CHCl2 in presence of H2O 373 kelvins. So CHO. Okay, this is the CHO. CHO means benzaldehyde. Okay, so first one we can take toluene in presence of chlorine and anhydrous chlorine to form what is methyl benzaldehyde, or this is the chlorobenzaldehyde. So in the presence of This is a chlorobenzaldehyde. In presence of H2 or 373 Kelvin to form benzaldehyde. Okay, this is the benzaldehyde. Okay, students. By side chain. Side chain means side chain chlorination of methyl benzene. Chlorination of methyl benzene means this is the side chain chlorination of methyl. Side chain means this is the ortho meta para ortho meta or para ortho meta para. Okay, this meta. This is side chain. It's called side chain also. Why? Because this is main chain. Okay, this is a side chain. This is also side chain. This is main chain. This is side chain, main chain. So side chain of methyl benzene forms benzyl fluoride. Methyl benzene forms benzyl fluoride to form which on hydrolysis gives aromatic aldehyde. This is a conversion. Okay. Next one, hydrolysis of benzyl halide. Okay. An aromatic aldehyde is obtained when benzyl fluoride is reacted with calcium hydroxide with the removal of water molecule. So we can take CH2. What we should take? An aromatic aldehyde is obtained when benzyl chloride is reacted with calcium hydroxide with the removal of water molecule. Okay, we can take first benzyl chloride. This is the benzyl chloride. What is benzyl chloride? Okay, this is benzyl chloride. Transfer calcium hydroxide H2O to form CHO benzaldehyde. Okay, students, and once again we can repeat. First one, oxidation of arenes. First we should take oxidation of aromatic hydrocarbons. In that oxidation of aromatic hydrocarbon such as toluene with manganese dioxide and sulfuric acid, benzaldehyde and to form benzaldehyde and aromatic aldehyde. Okay, this is the toluene. In presence of manganese dioxide and sulfuric acid, H2SO4 means sulfuric acid, to form benzaldehyde. Benzaldehyde means the CHO functional group which is attached with benzene to form benzaldehyde. Okay, next one, Itard reaction. In this reaction, toluene is oxidized to aromatic aldehyde. Benzaldehyde in the presence of an oxidizing agent, chromyl chloride. Okay, this is the chromyl chloride. This chromyl chloride oxidized methyl group to chromium complex. Okay, what should do? Chromic chloride oxidized with methyl group to chromium complex, which on hydrolysis gives the product. Okay, this is the toluene in presence of chromic chloride to form chromium complex. This is a chromium complex in presence of H3O plus. So this is the benzaldehyde. Okay, this is the benzaldehyde. Next one, Gattermann-Koch reaction. Aromatic aldehydes can be prepared. Arenes are treated with a mixture of carbon monoxide. Okay, arenes are treated with a mixture of carbon monoxide and the presence of anhydrous AlCl3 and a trace of cuprous chloride. In presence of anhydrous AlCl3 and a trace of cuprous chloride, and this is the benzene, and this is carbon monoxide and hydrogen chloride. In presence of AlCl3, aluminum trichloride and cuprous, this is AuCl not, this is a CuCl to form benzaldehyde. Okay, this is a benzaldehyde in presence of and HCl, hydrogen chloride. Okay, next one, by side chain chlorination of toluene. Side chain chlorination of methyl benzene forms benzyl fluoride. Okay, side chain of chlorination. This is a Toluene means CH3 group is present. Okay, students, CH3 group is present. So in the CH3 form benzyl chloride. So which an hydrolysis gives aromatic aldehyde. So this is the toluene in presence of Cl2H to form benzaldehyde. Okay, this is the benzaldehyde in presence in presence of H2O in presence of 373 kelvins. So to form benzaldehyde, this is the benzaldehyde. And the next one, hydrolysis of benzyl halide. In an aromatic aldehyde is obtained when benzyl chloride is reacted with the calcium hydroxide with the removal of water molecule. So this is the benzyl chloride in presence of calcium hydroxide to form H2 is outside, so to form CH4 benzaldehyde is formed. Okay, students, this is the only oxidation of NH. This is most important, and in exam point of view. So what should we do? First, we can take toluene. We know that toluene benzene which is attached with CH3 groups to form toluene. In the toluene, we can take manganese dioxide. This is the one of the reaction. Attard reaction is the one of the reaction. Gatterman-Koch reaction is the most important reaction. Why? Because it is asked in exams also. It will ask in exams also for 4 marks or maximum 4 marks, 4 or 3 marks. So we can write only definition and one structure. This structure, benzene with react with carbon monoxide and HCl, hydrogen chloride, in presence of AlCl3 to form benzaldehyde and HCl. This is enough. This is the enough. Okay. Next, students. Size of groups are substituents attached to a carbonyl group. Okay, side of groups. What is side of groups? Function groups. We know that function groups. The carbon which is attached with the functional groups is called side of groups. So larger groups prevent the attack of nucleophiles. Okay. What is larger groups? We know that carbon atoms which is attached with hydrogen atoms, that is one carbon which is attached with the 3 hydrogen atoms, that is the larger atom. The attack of nucleophile. Nucleophile means minus charges towards the carbonyl group. Aldehydes have only one alkyl group. Okay, aldehydes one alkyl group. Why? Because COH or C double bond OH, only one alkyl group is present. Whereas ketones have 2 alkyl groups. So ketones means RC double bond OR. Or next one is why? Because 2 alkyl groups means this is the ketones. Okay, this is the aldehydes. Only this have 2 alkyl groups. This only one alkyl group. That is the difference. To have 2 alkyl groups, the 2 alkyl groups in ketones sterically hinder the reactivity of carbonyl group. Hence aldehydes are more reactive than ketones. Okay, aldehydes are more reactive than ketones. Why? Because this have only one alkyl group, but ketone have 2 alkyl group. In the 2 alkyl group nucleophiles, 2 nucleophiles are attacked, but in that only one nucleophile is attacked. Nucleophile is a more electronegative atom. That's why this is a more react than ketones. Okay, students, the order of reactivity of carbonyl compounds towards nucleophile is as follows. Okay, this is the formaldehyde. Formaldehyde means which have no alkyl group, it is present. So C double bond OH. Okay, this is a formaldehyde. Next, this is RC double bond OH means aldehyde. What is aldehyde? RC double bond OH. Okay, this is the ketone. Why? Because RC double bond OR. Okay, 2 alkyl groups, which is ketones. 1 alkyl group, it is aldehyde. Without any alkyl group, it is the formaldehyde. Only that is name also stable formaldehyde. No one name is there. But in that C2H5, this is the ethanaldehyde. And this C2H5, C2H5. What is this ketone? So one. What is butanone? Okay, butanone are there. Why? Because C2H5. How many C's are there in that one? For example, C2H5 double bond C2H5. Okay, student. This in this two, total 4. So 4 carbons present. What should we take? Buta. Okay, buta. This is the ketone group. Functional group is ketone. So what should name comes? Butanone. Okay, this is the name. What is ketone's name? Butanone. Only four carbons. Otherwise 3 carbons. What is propanone? 2 carbons, ethanone. Or otherwise in aldehydes 1 carbon, methanaldehyde. 2 carbons, ethanaldehyde. 3 carbons, propanaldehyde. 4 carbons, butanaldehyde. 5 carbons, pentanol. That's enough. 4 carbons enough. Also there, butanone and pentanone or propanone, ethanone. So this is the. But methanone is not there. Inductive effect of the substituent groups. The effect of an atom or a group that withdraws or releases electrons is known as inductive effect. Okay, withdraws or releases. Either any reaction have that nature has withdraws or release. Any one option is there. Without option, it's nothing but in electrons and atoms and molecules. Okay, students. Atoms are groups which release electrons towards a carbon atom. That is, electron releasing groups exhibit positive inductive effect. Alkyl groups are electron releasing and thus have positive inductive effect. This positive inductive effect of an alkyl group decreases the reactivity of carbonyl group towards nucleophilic reactions. It is primarily due to the increase of electron density of carbonyl group. The ketones with the 2 alkyl groups exhibit greater plus inductive effect than aldehydes with none or one alkyl group. Thus ketones are reactive than aldehydes. Okay, ketones are reactive than aldehydes. In that steric group substance attached to carbonyl group, aldehydes are reactive than ketones. In that positive inductive effect, we have that ketones are more reactive than aldehydes. Okay, so this is a 2 also important, but this is only subject. We cannot subject only. In that previous classes, we discussed that inductive effect, and in first year also we discussed inductive effect. What is inductive effect, and what is mesomeric effect, and hyperconjugation. What is hyperconjugation? We know that. So these 3 are similar properties and similar like this. Why? Because this inductive effect also withdrawing and releasing, mesomeric also withdrawing and releasing, and hyperconjugation also withdrawing and releasing. But where that atoms are comes from, that's the point where that atoms are present. In functional groups, we can use inductive, mesomeric. In alkyl groups, we use the mesomeric only. In alkane groups, we use the hyperconjugation, and that is the spirit. Why? Because in functional groups we can use both inductive and mesomeric, but only hyperconjugation not there. In alkyl groups only we can use mesomeric or not inductive. That's the fluctuations in various mesomeric, various inductive effects, and positive inductive effect is a negative inductive. Yeah, positive mesomeric and negative mesomeric.